Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today I am creating a model mechanical bench vise in Siemens NX. In this video, you will learn the full modeling process of this model and its components. I have used 10 part files and one assembly to make this model. If you want to get the file of this model, its files are free for available here and can be downloaded easily. I have given the link address in the description of my video. By visiting that link, you can get it easily. Okay, that's it. Now this is the simple bench vise assembly. Each part will be created separately and afterwards all the components are placed into the main assembly. Okay, alright, so let's start the tutorial. Now activate the new button from here and select a new millimeter power file. Here I am changing the file destination so that the files that I create will be saved here by going to this folder. Create a folder named Mechanical Bench Vise. Okay, now you can see here. Alright, set the part name base and click OK to open a file. Let's make the first part of bench vise, which is named base. See here its drawing file. Now this sketch profile height is 55.55 mm by 69.85 mm. Okay. Now this inner slot height is 26.97 mm and the width is 31.85 mm. Okay, that's it. Top slot height is 15.89 mm and the width is 25.40 mm. The diameter of this big circle is 34.90 mm and the diameter of the small circle is 12.19 mm. The thickness here, see, 25.40 mm. So I hope that you have understood a little bit from the drawing sheet of this sketch. So now I am going to make and show you. Back to the power file. Now I am activating the sketch preferences option from here and deactivate the change view orientation option so that when I start the sketch on a plane, the view does not rotate automatically. Click OK. I am activating the sketch tool from here and select the YZ datum plane to start the new sketch. Now I am creating a rectangle here. Fix the coincident constraint between the midpoint of the rectangle line and part origin. The height and width of the rectangle will keep 55.55 mm and 69.85 mm. Okay, that's it. See, my rectangle is fully constrained on here. Now create another rectangle over the inside and fix the point on curve constraint between the midpoint of the rectangle line and the z-axis. Now this rectangle height will keep 26.97 mm and the width is 31.85 mm. Okay, that's it. Now draw another rectangle on the top side. Its width will keep 25.4 mm and height is 15.89 mm. Alright, now select these two rectangle lines and convert them into construction geometry. Create two more lines on the both sides of the rectangle like this. In the same way, convert this rectangle line into the construction geometry and draw the lines over this. Draw a circle on the top side and fix the point on curve constraint between the midpoint of the circle and the z-axis. Its diameter will keep 34.9 mm. And fix the coincident constraint between the circle and midpoint of the rectangle line. Okay, now convert the circle into construction geometry and draw a small circle inside. Its diameter is 12.19 mm. Fix the dimension 1.6 mm between the circle and rectangle line. Apply the vertical constraint between the center point of the circle and the midpoint of the rectangle line. Now I am creating two more lines on the both sides of the sketch like this. Now this line length will keep 17.48 mm. Okay, now I am creating a 3-point arc over the outer circle. The arc will be tangent to the outer circle. See, my sketch is completed here, so now I am exiting the sketch. And choose the isometric view. Let's activate the Extrude command from here and select the sketch region. Okay, fix the extrude distance value 25.4 mm and click OK. Now see here, my first base feature is created. I am enabling the true shading button from here. Go on the true shading editor command. Here I am selecting the brushed chrome material and disable the planar shadow, flow reflection and grounded plane options. Okay, alright. Now my feature is looking perfect. Okay, that's it. Now I am back into its drawing sheet file. Okay, next see here, I will create a sketch over the front face of the feature. The height of the sketch is 39.5 67 millimeter and extrude this sketch profile 127 millimeter. Okay, alright, now back to the power file. Now select the front face and start the sketch. I am activating the project curve command and select the front face for taking the project. Okay, alright. Now select the entire sketches and convert them into reference geometry. Now draw the lines on the reference curves like this. Apply the constant constraint between these two endpoints of the lines to close the sketch profile. Its vertical dimension will keep 39.67 millimeter. And finish the sketch. Now activate the extrude command and extrude this sketch profile 127 millimeter. I am selecting the unite option here so that my second extrude feature is added to my base feature which is already made, and click OK. Now I am creating a mirror of this extrude feature on the opposite side like this. See, my mirror feature has been successfully created. Now I am activating the edge blend tool from here and fix the fillet radius 6 millimeter. Give the fillet on the two outside edges of the model like this. Now fix the fillet radius 3 millimeter and apply the fillet on the two inside edges of the model. Now see, it is looking perfect. Okay, next I will create a sketch over the front face of the mirror feature of the model. The height from here is 44.45 millimeter. And then extrude it 31.75 millimeter. Okay, that's it. Now select the front face, sketch. Now take the project of both side faces and back face. Convert the entire sketches into reference geometry. Now draw two vertical lines and one horizontal line like this. Fix the dimension 44.45 millimeter from this line and this endpoint. Now draw some more lines over the projected sketch to close the sketch profile. Okay, that's it. Finish the sketch. Now activate the extrude command and extrude this sketch profile 31.75 mm. See, my extrude feature is created. Alright. Let's make an arc here. Its radius will keep 34.93 mm and add the dimension 30.15 mm between this endpoint to this endpoint. After creating this, I will remove this sketch with the help of extrude feature. Well, after making this feature, I will create 4 legs in the base part, the dimensions of which I have given here. Now this circle diameter will keep 56 mm and the inner circle diameter will keep 8 mm. The center distance of the circle 50 mm from the outside edge. Okay, alright, the height of the leg will keep 8 mm. And leg of the corner fillets will keep 6 mm. The extrude feature of the leg will remain the same, and after that 3 more will be created with the help of a mirror feature command. Okay, alright. Okay, now let's create a sketch on Vise datum plane. Take the project of the entire face and convert the entire sketches into reference geometry. Draw an arc on here. The arc radius will keep 34.93 mm. The vertical dimension will keep 30.15 mm and apply the tangent constraint between this arc and the side projected edge. Okay, now draw 2 lines as the same to close the sketch profile. Finish the sketch. Activate the extrude command and select the sketch profile. Okay, now I am selecting here symmetric value option and choose subtract option. Fix the value 100 mm and click OK. See, my curved surface has been created here. Now rotate the model on the back side. Okay, now let's create another sketch of this face for creating its leg. Take the project of the face and convert the sketch into reference geometry. Now draw an arc on here and create a small circle inside of the arc. Okay. The circle diameter will keep 8 mm and the radius of the outer arc is 28 mm. Now I will fix the vertical constraint between the center point of the inner circle and center point of the outer arc. Set the dimension 15 mm between the side edge and center point of the circle. Draw a vertical line to close the sketch. Finish the sketch. Activate the Extrude command and select the sketch region. Set the extrude distance value 8 mm. Double click on the extrusion arrow to change the direction. Now choose Unite option and click OK. See, the first leg is created. I will mirror this feature. Now activate the mirror feature command and select this extrude feature. Okay, now let me choose here YZ datum plane and click apply button. Now see, my two legs are made. I am going to make two more legs. So now activate the datum plane command from here and select the front and back face of the part. Okay, now see. Activate the mirror tool once again and select the extrude features and mirror feature. Select the mirror plane. Here I am selecting this datum plane. Okay, now see, my four legs are made. Now I will apply the fillets on the edges of the legs. The fillet radius is 6 mm. I will make a 3 mm fillet here on the outside edges of the part. Okay, alright, my base part is looking perfect. Next, I will make two tabbed threaded holes on the jaw face of the base part. This is an metric thread. The designation is M6 into 1.0. The thread depth is 16 mm and the hole depth is 22.35 mm. The location of the holes is shown in the drawing sheet. The distance value 25.4 mm between the center point of the hole and this edge. Okay. The second value 15.80 mm between this center point of the hole and the side edge. The distance value between the two holes will keep 38.10 mm. Now rotate the model in this position and activate the hole command from here. I am selecting the threaded hole option from the thread type list. At first, I will specify the sketch points for creating the hole. So let's start the sketch over the jaw face of the base part. Now I will make two center points and apply the horizontal constraint between these 2 points. Now I will give the dimensions on this point as I told you just before in the drawing sheet. Okay, finish the sketch. Now I select the M6 into 1.0 value from the thread size list. Now fix the thread and hole depth values according to my drawing sheet file. Here I will disable the start and end chamfer options and click OK to create the hole. Okay, alright, now see my holes are created here. I will give a chamfer on this whole edge. The chamfer distance is 2 mm and the angle is 45 degrees and click OK. Next, I will create a realistic thread with a sketch profile over the inside of this hole by using the Helix Curve and twisting the thread sketch profile by using the sweep tool. Okay, so let's see. Activate the Datum Axis command from here. Select the inner cylindrical surface of the hole. Okay, now see. Activate the Datum Plane command and select this axis. Then I will choose the XY datum plane. Click OK. My plane is created here. Now select this plane, sketch. Take the project of the entire body's face. Activate the section view by selecting this plane. Convert the entire sketches into construction geometry. Let me draw a thread sketch profile like this. Draw the two horizontal lines here. Fix the horizontal constraint between the midpoint of the lines. Now select these points and fix the vertical constraint. Apply the point on curve constraint between these two endpoints. Draw the two aligned lines on both sides. Draw the construction line over the mid of the sketch and fix the symmetric constraint between these aligned lines by selecting the construction line. The bottom line dimension will keep 1.37 mm. Its height is 1.84 mm. Set the angular dimension 28 degrees between these two aligned lines. Okay, alright, finish the sketch. Go on the Curves tab. So now I am activating the Helix tool from here. See the Helix curve visible in the design window. Rotate -90 degrees by selecting this node of the helix. Next, I will select the center point of this outer circular edge for placing the helix. Double-click on this arrow node to change the direction of the helix. Alright, in the helix dialog box, I fixed the helix diameter value 12.19 mm. Helix pitch will keep 3.5 mm. Now choose the turns option under the helix method section and set the turns value 10. Here I will fix the angle value 180 degrees so that the helix starts from our opposite side. Helix turn direction will keep left hand and click OK to create a helix. See, my helix is successfully created. Now I will activate the sweep command. First, I will select the thread sketch profile and then next I will choose the helix curve. Now see, the preview is visible. But here my thread is not showing properly in the right direction. That's why I have to go into its settings and fix it. So let's see. Now I activate the preserve shape option here. Under the orientation section, I will choose the vector direction option instead of fixed. Here I will select this pink arrow to specify the swept direction. Okay, that's it. Now see its preview. It seems to be going in the right direction. Click OK. Now I will activate the subtract command. First select the base and then I will select the swept feature and click OK. Now see, my realistic thread is looking very nice. With this, my base part has also been completed here. Okay, that's it. So now I am closing this part file. Now I am creating the next part, Vise screw. Okay, let's see its drawing sheet file. The total length of the screw will keep 160 mm. Now see, in the left side, this radius will keep 9.50 mm And this dimension from here to here is 20.65 millimeter. This slot distance is 6.35 millimeter, and the height will also keep 6.35 millimeter. The edge of the screw radius will keep 1.5 millimeter. This dimension from here to here is 100 millimeter. See in the right side, this dimension will keep 23.30 millimeter. And this slot horizontal dimension is 3.35 millimeter. Now this slot vertical dimension is 4.75 millimeter. See in the section view, the whole diameter will keep 8.75 millimeter. The circle will be placed over the center of this feature. The sketch profile of its thread and where to keep it, I will tell you during the sketching of the part. The sketch profile of the thread will be the same as I showed you earlier. So let's start. Now create another new millimeter part file from here. And set the name Vise screw. Okay, alright. Now I am selecting the datum plane sketch. Draw a horizontal line and apply the coincident constraint between the midpoint of the line and part origin. Its length will keep 160 millimeter. Now I am creating some more lines with the given dimensions like this. This vertical dimension will keep 6.35 millimeter. And this horizontal dimension will also keep 6.35 millimeter. Now this dimension is 1.6 millimeter. And this line length will keep 100 millimeter. Now draw the lines on the left side of the sketch. Okay. Apply the dimension 23.3 millimeter over this line. Now select this endpoint of the line and the baseline and fix the dimension 4.75 millimeter. This small line length will keep 3.35 millimeter. Now create two more lines to close the sketch profile. Here I will fix the collinear constraint between these two lines. Okay, and its height will keep 6.35 millimeter. Now my sketch is fully constrained, so I will finish the sketch. Activate the Revolve tool from here and revolve the sketch like this. Okay, now see my revolve feature has been created here. Now I am activating the true shading button and change the material part as brushed groove. See, my part is looking perfect. Now I am applying the chamfer on this edge. The chamfer distance will keep 1.5 millimeter and angle is 45 degrees. Apply the fillet on opposite side edge. The fillet radius will keep 1.5 millimeter. Now I am starting the sketch on exact datum plane. Take the project of the entire body's face. Now activate the section view by selecting this plane. Convert the entire sketches into reference geometry. Now I am creating the thread sketch profile here in the following way. I will apply the same dimensions on the thread sketch profile as I had done earlier in my previous model. Apply the dimension 1.5 millimeter between this corner endpoint and endpoint of the thread sketch profile. Okay, finish the sketch. So now I am activating the Helix tool from here. Rotate the minus 90 degrees by selecting this node of the helix. Next, I will drag the helix center point from here and place the helix curve over the outer circular edge center point like this. Okay, alright. I fixed the helix diameter value 15.19 mm and enter the helix pitch 3.5 mm. Choose the turns option under the helix method section and set the turn value as 29.25 and click OK to create a helix. See, my helix is successfully created. Now I will activate the swept command. First of all, I will select the head sketch profile, and then next I will select the helix curve. I select the preserve shape option here. Now I will choose the vector direction. Here I will select this pink arrow to specify the swept direction. Click OK. Okay, that's it. Now activate the subtract command. First select the base and then I will select the swept feature. And click OK. Now see, my realistic thread is created over the cylindrical surface. It is looking very nice. Next, I will make a hole over the cylindrical surface of this Vise screw. Create a sketch over this plane. And take the project of the entire body. Activate the section view. Convert the entire sketches into reference geometry. Now draw a circle diameter of 8.75 mm. Fix the horizontal constraint between the midpoint of this line and circle center point. Fix the vertical constraint between the circle center point and this top line. Okay, finish the sketch. Here I will activate the Extrude command and cut this circle on both sides from the center plane. Okay, that's it. Now see, my part has been completed here. So now let me talk about making my next part. My next part is sliding jaw. This is also a main part of this assembly that I am going to make. See the drawing sheet here. The base sketch dimension is here. Now see this rectangle dimension here. Now see this rectangle dimension is 69.85 mm by 44.54 mm. Okay, this vertical dimension will keep 38 mm. Now this dimension from here to here is 12.88 millimeter. This slot width is 5.56 millimeter. Okay. The slot height is 4.78 millimeter. Now this dimension from here to here is 25.4 millimeter. Okay, that's it. Here I will also make the two tabbed holes on the face of the sliding jaw part. The hole will be made in the same way as earlier I made the hole in my base part. The location of the holes is shown in the drawing sheet. The distance value of 25.40 mm between the center point of the hole and this bottom edge. The second value of 15.88 mm between this center point of the hole and the side edge. The distance value between the two holes will keep 38.1 mm. Okay, that's it. After creating this, I will create a taper sketch profile on its side face. The dimension is given below. Now this horizontal dimension is 65 mm and its height will keep 34.93 mm. And the angular dimension is 74.7 degrees. Okay. See here on the top side, this arc radius will keep 34.93 mm. This dimension is 8.54 mm from the side edge and the end point of the arc. Now this vertical dimension is 25.54 mm and this line dimension is 14.71 mm. This inner fillet radius is 6 mm and the outer edge fillet will keep 3 mm. And the fillet of the outside model edges is 0.5 mm. So come first, I am going to make it and I will tell you the dimensions of the rest of the features later. Okay, that's it. So let's start. Open a new millimeter part and set the name sliding jaw. Okay. Select the YZ datum plane, sketch. Draw a rectangle on here and fix the coincident constraint between the midpoint of the rectangle line and part origin. The rectangle width and height will keep 69.85 mm by 44.54 mm. Draw another rectangle on the bottom side and fix the vertical constraint between the midpoint of the bottom rectangle line and part origin. Now this rectangle line length will keep 38 mm and the width is 25.4 mm. Fix the coincident constraint between the midpoint of this rectangle line and part origin. Okay, that's it. Now I will create two more small rectangles on both sides of this base sketch. Apply the collinear constraint between these two rectangle lines. In the same way, apply another collinear constraint here. Now select these two vertical lines and apply equal constraint between them. Now I will fix the dimension 12.88 mm on this line. and fix the horizontal line dimension 5.56 millimeter. The vertical line dimension will keep 4.78 millimeter. I will convert the outer lines and top rectangle lines into reference geometry. And draw the lines something like this over the projected line to close the sketch profile. So now my sketching is completed here. Finish the sketch. Activate the extrude command and select the sketch. Change the extrude direction on the back side. Extrude this sketch profile 40 millimeter. OK. Activate the true shading button and change the material of the part. See, my part is looking perfect. Now I am going to create a new sketch over the side face of this part for creating a cylindrical surface. Now take the project of this face and convert the entire projected sketches into reference geometry. Draw two horizontal lines over this face like this. This horizontal line dimension is 8.54 millimeter and this vertical line dimension is 25.54 millimeter. Fix the dimension 14.71 millimeter between the side edge endpoint and the endpoint of this line. Now draw an arc between these two line endpoints. OK. The arc radius will keep 34.93 millimeter. OK, that's it. Now I will cut this sketch profile by using the extrude command. OK, now see the result. Now I will give the fillet on this edge. My cut feature is looking perfect. Here I will create another extrude feature on this face. and later I will create a tapped hole over this extruded feature. Now see here, its dimension is given in the drawing sheet file. The arc radius will keep 17.46 mm and the arc height is 15.86 mm. The tapped hole specification is given here. It will keep 7 by 8-9 UNC. Thread depth will keep full depth and hole depth is 30 mm. Okay, alright, so now I am starting a sketch on this face. Draw a 3-point arc on this edge. Fix the point on curve constraint between the arc center point and z-axis. Its radius is 17.46 mm. Draw a sketch point on here. Fix the sketch point over the midpoint of the arc. Apply the vertical dimension 15.86 mm between the midpoint of the arc and bottom edge. Okay, that's it. Create a horizontal line here to close the sketch profile. Finish the sketch. Now activate the Extrude command. Select the sketch and click on this arrow to reverse the extrusion direction. I am selecting the Unite option here. Now I am selecting the Until Extended option. And then select this curved surface. And click OK. Now see my extrude feature is created. Okay, now I am applying the fillet 3 mm on this arc edge. And this outer edge. Now see my part is looking perfect. Now I am going to create another sketch over the side face of this part for creating an aligned face. Now take the project of this face and convert the entire projected sketches into reference geometry. Draw a sketch profile like this. Now this vertical dimension is 34.93 mm. And fix the angular dimension 74.74 degrees between these two lines. Now select this endpoint of the line and the side edge and fix the dimension 65 mm. Okay, finish the sketch. Now I will activate the Extrude command and select this sketch. I will select the until extended option and select the opposite side face of the model. Click OK. Now see my tapered face has been created here. Start the sketch on the back face. Draw the two rectangles over this slot edge. OK, and cut this sketch profile through all over the body by using the Extrude command. Now see the slot is created here. Now I will apply the fillet on this edge. OK, that's it. Activate the hole command from here. At first select this face to set the location of the hole. Here I am fixing this sketch point by using the coincident constraint. OK, finish the sketch. I am changing the thread standard here. Now I select the inch UNC from the thread standard list. And thread size will keep 7 by 8-9. Thread depth is full. And hole depth is 30 mm. Disable the start and end chamfer of the hole edge and click OK. Now see my threaded hole is created on this face. Next I am making two more threaded holes on the jaw face of this part. Here I am going to make the same hole as I made earlier in my base part. Now see my thread holes are created on this face. Okay, it is looking very nice. Okay, that's it. Next I am making two more holes in the bottom of this part. The details of which I have given on my drawing sheet you can see from here. the 30 mm dimension between the bottom edge and hole center point. 15.88 mm will keep between these two holes. Okay, first of all, I will make the two simple holes. And afterwards, I will create an ANSI unified screw thread over the simple holes. The designation is 12-24 UNC. The thread depth is 19 mm and the hole depth is 24.5 mm. Okay. Rotate the model in the back side and activate the hole command. Now select this face to location of the hole. Create two sketch points here and draw a reference line over the mid of this face. Now I will fix the vertical constraint between these two sketch points. Apply the dimension 15.08 mm between the sketch points. Now select this point and the side edge and apply the dimension 30 mm. Okay, alright. And fix the symmetric constraint on these sketch points by selecting the reference line. Okay, finish the sketch. Now select the general hole option from here. The hole diameter will keep 3.797 mm. And its depth is 27 mm. The hole tip angle will keep 0 degrees. And click OK to create a hole. Okay, that's it. My holes are created on the bottom face. Now I will create a thread over the hole. Activate the hole command once again and select the threaded hole option from here. Now select this face for locating the center point of the hole. Here I will snap the sketch point over the previous hole center by using a coincident constraint. Finish the sketch. Here I select the along vector option. The hole designation will keep inch UNC. Thread size will keep #12-24. Okay. Thread depth will keep 0.748 inch. And hole depth will keep 0.9646 inch. Click OK to create the thread. Now see the result. In the same manner, I will apply the thread over the second hole. Now I will show this arrow to locate the direction of the hole. Okay, finally my thread is applied on these two holes. Now I am applying the fillets on the outer model edge. The fillet radius is 0.5 mm. Okay, now my sliding jaw part is looking perfect. The part is completed here, so close the par file. Now I am creating some more miscellaneous parts of this assembly. I am going to tell you about this by demonstrating directly. I have not shown its dimension in the drawing sheet. First off, I am creating a first small part, jaw plate. Okay, so let's start. Start a new part file. Okay, and start the sketch on XZ datum plane. Now draw a center point rectangle over the part origin. The height and width of the rectangle will keep 44.45 mm by 69.85 mm. And extrude it 5 mm. Okay, that's it. Next, I am creating the two counterbore holes on this face. Activate the hole command and select the general hole option. Now select this face for locating the center point of the hole. Okay, now create two sketch points on here. And fix the horizontal constraint between these 2 points. Select this point and the bottom edge and apply the dimension 25.4 mm. Fix the dimension 38.1 between the two sketch points. Now draw a reference line over the mid of this face and fix the symmetric constraint on these 2 points by selecting the reference line. Okay, that's it. Finish the sketch. Now choose the counterbore hole option here. Counterbore diameter is 0.47 inch. And counterbore depth is 0.14 inch. The diameter of the hole is 0.266 inch. Okay. The hole depth will keep through all over the body. All the dimensions will keep in inches. And click OK to create the hole. Now I am applying the fillets on the outer edges of the part. Fillet radius is 0.5 mm. Now it is looking perfect. Next, I am creating a realistic knurling on this jaw face. Now select this face, sketch. Take the project of the entire face and convert them into construction geometry. Draw a aligned rectangle like this by using the 3-point rectangle tool. The rectangle width is 1 mm. The rectangle aligned length will keep 82 mm. Select this line and select the aligned line and fix the angular dimension 135 degrees. Apply the dimension 5.8 mm between the bottom edge and this endpoint of the rectangle line. Apply the dimension 1 mm between this endpoint of the rectangle line and the side edge of the part. Okay, now my sketch is fully constrained on here. So I am creating the linear pattern of this sketch profile. I am activating the pattern curve command from here and select this rectangle. Okay, now select the x-axis of the part for defining the pattern direction. Now I select the reverse direction option. Spacing will keep count and pitch. Fix the count value 52 and set the pitch distance value 3 mm. And click OK to create the pattern the sketch. Okay, now see my sketch pattern is created here. Finish the sketch. Now I am activating the extrude command and select this sketch. It will automatically select all the rectangles. Click on this arrow to change the extrusion direction. Fix the extrude distance value 1 mm. I select the subtract option. Now I am selecting the from start limit option under the draft area and set the draft angle value 15 degrees. Now zoom the feature like this for checking the taper distance direction. If its direction is wrong, then you can change the taper value to plus or minus and click OK. Now see my first knurling is created. Next, I will create the mirror of this cut extrude feature on the opposite side of the part so that its shape is converted into a triangle. Now activate the mirror tool from here and choose the cut extrude feature. And now select the YZ datum plane and click OK. Now see the result. My realistic knurling has been successfully generated here. It is looking very nice. So now my part is completed here and close the part file. I am creating a next part named slide key. Okay, so let's start. Start the new part file from here. And start the sketch on XZ datum plane. Now draw a center point rectangle over the part origin. The width and height of rectangle will keep 60 mm by 8.64 mm. Create another rectangle on here and fix the constant constraint over this. Now this rectangle width and height is 4 mm by 3.25 mm. Okay, alright. Convert the top two rectangle lines into reference geometry. And draw the lines over the construction line like this. Okay, alright. Finish the sketch. Now extrude this sketch profile 4.75 by 2 mm. Okay, now close the bar file. Open another new millimeter bar file from here, which is named special key. Now select the XZ datum plane, sketch. Let's draw an arc on here. Apply the point on curve constraint between the center point of the arc and sketch vertical axis. Its radius will keep 5 mm. Apply the coincident constraint between the midpoint of the arc and part origin point. Now I will draw the two small vertical lines on here like this. Create another arc here on the outside. The center of both the arcs will be the same here. Now I am fixing the tangent constraint between this arc and vertical line. Okay, alright. Finish the sketch. And extrude this sketch profile 3.25 mm. Now close the par file. Here I am creating a collar part. Okay. And start the sketching on XY datum plane. Draw the two circles from the part origin. One circle diameter is 13 mm and the second one is 18.25 mm. Finish the sketch. And extrude this sketch profile 20 by 2 mm on both sides from the center plane. Change the material of the part as brass. Okay, my part is looking perfect. Now select the front face, sketch, draw a center point rectangle on here. Its height and width is 20 mm by 2.36 mm. Okay, finish the sketch. Now I will create 3.25 mm deep cut this sketch profile from the front face. Okay, now my part is finished here and close the part. Next I will create a part handle rod. Now select the YZ datum plane, sketch, create a circle 8 mm dia from the part origin. And extrude this circle 120 by 2 mm on both sides from the center plane. Now change the material of the part as brushed aluminum. Now save the part and close it. I will create the next part, handlebar. Okay, and start the sketch on YZ datum plane. Draw a vertical line. The line length is 19 mm and fix the line over the part origin by using the coincident constraint. Create an arc on here and the arc radius is 9.5 mm. Okay, finish the sketch. Now I am activating the Revolve tool and revolve this sketch profile. Start the sketch on XY datum plane. Create a circle on here and its diameter will keep 8 mm. And cut this sketch on both sides from the center plane. See, my hole is created here. Now I am creating another small hole on its side face. The hole diameter is 2.64 mm. Now see, a small hole is made on the side here. Now the part has been completed here, so close the part file. Now I am creating a small pin here. Okay, and this is the last part of my bench vise assembly. After that, I will create the main assembly. Okay, alright. Start the sketching on XZ datum plane. Now create a horizontal line here and fix the line over the part origin. The line length will keep 8 mm. Now create another line on the top side. Okay, apply the point on curve constraint between the midpoint of the line and sketch vertical axis. The top line length will keep 7.2 mm. Create two vertical lines here and its length is 1.14 mm. Fix the dimension 1.25 mm between these two lines. Create two more lines to close the sketch profile. Now I will revolve this sketch. Okay. And change the material of pin as gold. Okay, now my pin is looking perfect. Okay, alright, close the part file. Okay, that's it. Finally, all the part files of bench-wise model are finished here. So now I am creating a new millimeter assembly file in Siemens NX. Set the name of the assembly mechanical bench-wise here. Okay, that's it. Now my assembly design window is visible on your screen. Various assembly tools are available here. Now you can see. Now the add component command has already been activated here. I will select the base part. Okay, now select object button from here. You can see the preview of the component is visible in the assembly design window. Okay, here I will select the WCS button from here so that the XY coordinate of the part can be seen. I will rotate the base part 180 degrees by selecting this node. And fill the 0 value under the Y and Z coordinates of this part, so that the origin of my part and the origin point of the assembly both become 1. Here I will choose the entire part option, so that whatever sketch or plane of my part I made in it, all of them are visible in this assembly. Click OK. See on this dialog box, it will ask you that it is the first part that you place in this assembly. Do you want to fix it? Click yes button. Okay, that's it. I will activate the degree of freedom button and check the degree of freedom of the base part. Now see the result. There is no degree of freedom in this part because the fixed constraint is automatically applied. Okay, that's it. Now I will hide the visibility of the entire visible work planes and sketches of the part by using the show and hide button. I will activate the True Shading button to make my assembly look better. I will open the Visualization button from here. I select the Extra Fine button. Okay, now see my assembly edges are visible much fine. So now I will place the jaw plate by using the Add Component command. Okay, now activate the Assembly Constraints command and apply the touch constraint between the front face of the base part and back face of the jaw plate. Here I will select the Align constraint and fix the Align constraint between the front face of the base and jaw plate part. Now I select the top faces of these two components and apply another Align constraint. Okay, alright, now see here my jaw plate is fully fixed over the base part. Hide the visibility of the assembly constraints by using the Show Oblique Hide button. So now I will insert the next part. Insert the ANSI M5 in 2.8 screw in this assembly. Rotate the screw 90 degrees by selecting this node. Activate the assembly constraints command. I select the Infer center axis constraint. Okay, and then next I will select the axis of the screw and the whole axis of the jaw plate. Okay, and apply the axis made between them. I select the touch constraint here. Fix this constraint between the whole face of jaw plate and back face of the screw. See, my screw is fixed on the hole. In the same way, I will fix another screw on the second hole of the jaw plate. So now I will insert the next part. My next part is sliding jaw. Okay, I select the absolute displayed part option, rotate the part by selecting its node. Activate the assembly constraints command and fix the touch constraint between the top face of the base part and back face of the sliding jaw part. Okay, now I fix the align constraint between the YZ plane of sliding jaw and YZ plane of the base. Now check the degree of freedom of this part. This red arrow is showing that my part can move forward or backwards. Here I will also test this part by dragging the move component command. Okay, now see the result. Next, I will insert another copy of jaw plate in this assembly. And fix the jaw over the sliding jaw part by using the assembly constraints in the following way. In the same manner, I will insert two more copies of the screw on here. And fix these screws over the second jaw plate. Now see, my second jaw plate and screws are properly fixed over the sliding jaw part. Now rotate the assembly in a backward direction. Here I will insert the two copies of ANSI 8-32 UNC screw in this assembly. Fix the screws over this hole in the following way. Now see, my screws are properly fixed over the back hole of the sliding jaw part. So now I will insert the next part. My next part is the slide key. Here I will insert the two copies of this part. Fix the touch constraint between the back face of the slide key and the inner slot face of the jaw plate. Now select this slot face and select the top face of the slide key part and apply another touch constraint between them. Okay. Now I select the align constraint here and fix the align constraint between these two faces of the part. In the same manner, I fixed the second slide key on the opposite side slot of the sliding jaw part. See, both slide keys are fixed on the sliding jaw part. Okay, now see my sliding jaw is perfectly running over the base. It is looking very nice. Next, I am inserting the Vise screw in this assembly. Rotate this part in this position. Now activate the assembly constraint tool. Now select the axis of Vise screw. Then next, select the whole axis of the base part and apply the Infer central axis constraint between them. Drag the Vise screw like this. Okay, alright. Insert the Vise handle in this assembly. Rotate the handle in this position. Now select the axis of the handle. And next, I select the whole axis of the Vise screw and apply the Infer central axis constraint between them. I will apply the touch constraint between the YZ plane of the handle rod and XY plane of Vise screw. Okay, rotate the handle like this. See here, my handle is fixed over the center of the Vise screw. Now I will insert the handle ball part. Fix the Infer central axis constraint between the whole axis of ball part and handle axis. Drag the handle ball in an upward direction. And apply the concentric made between the top edge of the handlebar and handle rod. Okay, I will choose the angle constraint. Select the YZ plane of the handlebar and XY plane of the handle rod. Then apply the angle made between them. Angle mate will keep 180 degrees. Here I insert the pin bar. And fix the pin over the small hole of the handlebar part. In the same way, I will fix one more handlebar and pin part on the opposite side of the handle. Insert the collar part in this assembly. Okay. And apply the Infer center axis constraint between the whole axis of collar part and whole axis of sliding jaw. Now I will apply the align constraint between the front faces of these two components. Okay, that's it. Fix the angle made between the slot face of the collar and side face of the sliding jaw. Now check the degree of freedom of the Vise screw part. This red arrow is showing that my part can move clockwise or anti-clockwise. Okay, alright. Now I will insert the special key part in this assembly. And apply the Infer center axis constraint between the whole axis of special key and axis of Vise screw. Next, I will fix the touch constraint between the top face of special key and back slot face of the Vise screw. I will activate the move component command from here and drag the Vise screw like this. I will activate the assembly constraints command, select the distance made from here. I will fix the distance made between the back face of the special key and front face of the sliding jaw part. Set the distance value 0.1 mm and click OK. Okay, that's it. Finally, my mechanical bench vise assembly is completed on here. I will activate the move component command from here. Now I am rotating the Vise screw like this and dragging the jaw plate on here. See here, it is perfectly running on the base part. Now rotate the assembly in this position. Okay, now see the result. It looks great. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. So now I will meet you in our next video. Okay friends, bye bye and have a nice day.